All right, let's get started. I haven't done this for a while. So, hey Max, how's it going? Yeah, I haven't done this for a while. Hopefully the setup is still fine. Um, we had to kind of change floors at the office here, so I'm in a totally different room. Kind of still the same setup. I have a big monitor over there. I have my laptop screen. I still haven't invested in a separate camera yet, so I can appear like I'm at the same level as the camera. So I'll be looking up a lot because that's where I kind of see what everybody else is looking at. Anyway, let's get started. Um, so it's been a while. I think what we're going to do today, what I was going to do anyway, and I thought, well, I might as well stream it, is that I'm working on a demo, a very simple demo, it's like about a 10-minute demo for basically demonstrating almost like an intro to Azure Functions. And I thought, well, usually what I do is I would start off by building a REST API using Azure Functions, really simple, and it would be backed by Cosmos DB usually. And usually a few lines of code for every endpoint, and it's a pretty neat demo in that it shows off kind of the power of the bindings in Azure Functions, as well as how quickly it is to stand up an HTTP endpoint in Functions without really doing any work. But what I thought we'd do today is work on a slightly, maybe more interesting demo in that, so the end app is a pretty simple, kind of like a chat application. You go to basically a standard static website, and what you would get is basically a chat box and all the messages to show up. So if anyone's ever seen any kind of, SignalR demos, it's basically that. But the only difference is that instead of using SignalR in ASP.NET and actually writing an ASP.NET app that hosts a SignalR hub that all the browsers connect to, we'll be using a new service in Azure called Azure SignalR Service, which is based on SignalR. And I guess the main scenario that it supports is that traditionally to scale out something like SignalR or Socket.io, you have to spend quite a bit of work to stand up a backplane. Whether it's Redis, in the case of SignalR, it also supports Service Bus and SQL Server. But those aren't easy to set up. And the reason you need the backplane is that as soon as you scale out to multiple instances of your server, different web clients or different clients will connect to different instances of your server. And when one of them wants to broadcast a message to either everybody or just to a select group of connections, without that backplane, it would only just be broadcasting to the ones that that particular instance is connected to. But then the rest of the clients won't get the message. So the backplane helps the different instances on the server side to talk to each other. So one of the main scenarios of the Azure SignalR service is to make it like super easy to scale out your SignalR application, in that you don't worry about scale out at all. Basically, what it does is it routes every single, like all the clients actually connect to the service, and the service handles all the scale out as you kind of dial the connections up and down. And your ASP.NET application will more or less just, like if it wants to scale to multiple instances, it can do that, but it doesn't need to scale out if it doesn't need to, because all the clients are connected to the SignalR service instead of directly to the application itself. So that's the main. I guess that was the initial driver for building the service, I think. But what the service also allows is for other languages to use it without using ASP.NET, so that you basically have almost like WebSockets as a service. So the last couple of weeks, we've been working on sort of understanding how we can actually move that forward, how we can support multiple languages, how we can connect it easily from different services in Azure, and really beyond. So we see Azure Functions is as a key player in this, in that if we have good integration with Azure Functions to SignalR service, that gives us a way to broadcast serverlessly to a bunch of connected clients. And then because Azure Functions integrates so well with all these other Azure services, that all this would just light up, right? So if you want Event Hub messages getting broadcast to a bunch of browsers in real time over WebSockets, that would enable that. If you want things like Event Grid, Service Bus, REST calls to broadcast to a bunch of clients, which is what we're going to essentially build today with the chat app. Or even like basically, something happening in, basically like a document being created or updated in Cosmos DB. All that will be all that will be supported by having a good scenario between a good integration scenario between Azure Functions and SignalR service. So what we did was that we built a sort of like an experimental set of bindings for Azure Functions to talk to SignalR service. It works pretty well. So I basically just whipped it together on a weekend and published it to NuGet. We got some pretty good traction. There was a couple of people that tried it out already and blogged about it initially. And then the other reason why the connection, the integration with Azure Functions is so important is that it's because Azure Functions is supports many languages. So obviously it supports C# and F# in the .NET world, but also supports JavaScript, Python, Java, and hopefully a few more as we go forward. So if we have one set of bindings that work well between for Azure Functions to talk to SignalR service, then any language that we add to the Azure Functions runtime will just automatically be able to talk to SignalR service. So that's the other driver behind kind of trying to get this integration working. And we're currently talking with the Azure Functions team and SignalR team to see how we can kind of take that forward. So it's pretty interesting. So what you're going to see today is kind of pretty preliminary stuff, but it works well enough. And like I said, I'm going to build a demo and I'm going to try to show it off because it's a little bit more interesting than just showing off some REST API. Yeah, so let's see what we can do here. It's been a while, but this is the Azure portal. So I think what I'm going to do is I'll create this app's going to talk to a SignalR service, and it's also going to talk to a Cosmos DB database. So I'm going to stand those two things up because both of those take about 3 to 4 minutes to create each. Oh, hey, Max, you're in Madrid? Nice. How's the weather there? All right, so to create a SignalR service, I need to spell it properly. And there is right there in our Azure portal. We'll go ahead and click create. And we'll have to give it a name. So it'll be like SignalR chat. That taken. Oh, nobody took it. Good. So, and I'll call this resource group SignalR chat. And we'll create it in West US, nice and close to me. And we'll choose a pricing tier. So, it looks like we have the free tier enabled already, which is great. So yeah, so we're going to have a free tier. So that free tier is not going to, I believe, is not going to have an SLA. But it's going to allow up to 100 connections. So, so for many apps that I've built before, I've had a hard time actually getting 100 people to use it. So, and this chat app will be no different. So it's really looks like it's going to be a great way to get started on it, basically for free. But we're going to go choose a standard because Microsoft pays for my Azure bill. And then what we can do here is actually just scale it up and down. I think each one of those units gives us 1,000 connections each. So if we need to scale out to 10,000 connections, there's a little dial here. I'm going to click Create. And that's going to go ahead and deploy it. While that's going, I'm going to go ahead and create a Cosmos DB as well. So Cosmos DB, for those new to Azure, is our kind of NoSQL, globally scalable document store, I would say. And it has its own native API. So if you kind of look at the APIs here, it has its own native API, which, funny enough, for a NoSQL database, you query with SQL. But behind the scenes, we're storing it in in basically like a JSON or document format. So you can basically chuck anything in there that you want, and you can query it out with SQL still. Really great and powerful, and it's completely cloud native, which means that you can scale the thing up and down as you need it. And there's no VMs behind the scenes. Well, there's still VMs like way down there, but you don't worry about VMs. You just literally tell it how many units you want, and we just scale up and down. And also, it literally supports replication to any of the 40 plus Azure regions around the world, just with just a click of a mouse. So if you need your data to be super close to your applications, you can do that. You can read from any of those replicas that you want. And just recently, a couple weeks ago at Build, we also announced that we're supporting multi-master writes as well. So what that means is you can actually write to your closest master. And basically Cosmos DB would more or less figure that out. I actually haven't dug too much into it. I believe there's also a conflict resolution kind of API there in case you have basically a write to the same record in two different regions, and you sort of have to kind of figure out what to do when that happens. So I think that's rolling out. I don't want to speak too much about it because, to be honest, I don't know too much about it. But that's pretty exciting to see that come out. So another great thing about Cosmos DB, and I actually used this before I joined Microsoft, was actually use Cosmos DB as with a Node application that talks to MongoDB. So Cosmos DB exposes itself with multiple APIs. So MongoDB is one of them. So if you don't want to use the native SQL API to talk to it, you can actually use any MongoDB driver and basically talk to Cosmos DB as if it was MongoDB. But the benefit of that is, again, it's completely cloud native, so you don't have to worry about sharding. And basically setting up different replicas and stuff in MongoDB. All that's managed for you. It scales up and down in basically seconds. And with a few, again, just like using the SQL API, with a couple of clicks of the mouse on a map, you can literally replicate that data all over the world. And your app just has no idea. It'll just talk to the closest replica that's available. So that's pretty neat. And also you can talk to it using Cassandra API. In Azure, we have another kind of NoSQL storage called Azure Tables. So you can also talk to it using the Azure Tables API. And another one that I kind of used in the past is the Gremlin API for basically building a graph database. So so behind the scenes, it's still Cosmos DB, but we built kind of a graph engine into it, and you can basically create your data set, both your vertices and your edges in your Cosmos DB. And you can query it using Gremlin, which is a standard syntax or language for querying the Apache Tinkerpop stack of graph databases. So yeah, anyway, let's actually create one. So we're just going to use the SQL API that happens to work best with Azure Functions. So that's what I'm going to use. I think I'm just going to call it the same thing. We're going to SignalR chat, and we'll drop it into the same resource group. I think it's called SignalR chat. WestUS sounds great. And here you can see that we can enable multi-master. I believe is only probably available in certain, well, you got to sign up for a preview, but that is available if you want to go check it out. And I think that's all I need to create this thing. So what I'm creating here is what's called a Cosmos DB account. Within an account, you can hold multiple databases. And within the databases, you have, you can create as many, they're called containers behind the scenes. But for basically NoSQL documents, they're typically, we refer to them as collections. So there would be collections in the SQL API, and also, that's equivalent to a collection in MongoDB as well. And then in a graph, that's like the container itself. It's basically a graph. So while that's creating, let's create an Azure function. So, and also typically what I do with this demo is I would do it in the portal. It's really easy to get started. You basically create an Azure function in the portal. We'll still do that. Actually, we might as well do that now too, even though we're not actually going to work in the portal right now. Since I'm here, I'll create that as well. So this one's going to be called SignalR Chat as well. Hopefully nobody took that name. Good. And we'll also drop in the same resource group. Windows is fine, consumption plan is fine. We'll also put it in WestUS so everything lives together. It needs a storage account to basically store logs and other things. So we'll just take the default name. We basically get application insights for free on it, so I would always click on. And that gives you really good metrics into your application. So we're going to go ahead and create that. Okay, so now we're going to work on some Azure functions, but instead of working in the portal, I think what we're going to do is we're going to work in locally on my Mac in VS Code and the function CLI tooling. So hopefully that works out okay. So let's go here. Where am I right now? I have a folder for Twitch stuff, so let's go there. And I will create. Hardest part is to name something. SignalR chat demo. Oops, I gotta make directory first. SignalR chat demo. Here I am. So let's create a couple of folders. Let's create a folder for the function app itself. And we'll also need a folder for content. So that would be the HTML file that actually show that actually renders the UI for actually typing in the chat. We'll go into the function app. And to create a function app, so right now it's an empty folder. All you have to do is type func init. And that creates, oh, I gotta choose one. I want node. And that creates a few things. So it creates a host.json. So that's basically, that has a bunch of settings in there, or you can put a bunch of settings in there that configures the entire function app instance. And it also creates a local.settings.json. By default, that's not committed to source control, and that's just for storing secrets locally as you're developing. When you deploy it to the cloud, typically you would put in app settings to basically supply things like connection strings. So in our case, well, I guess we'll probably have settings for the connection string to Cosmos DB, and also the connection string to SignalR service. So let's see how things are going. Making sure we're not missing anything in the chat. All right, so we're going to keep going. So now we're going to open up an instance of VS Code. We'll do most of our work in here. So what should we do? of like a chicken or the egg thing. Actually, I'm going to get out of this. I want to open it up at a higher level. So I think what we want is we need an index.html. Actually, you know what? I already have something there for this. So let's go hunt it down. So I already have basically a shell of a chat app already built. So let's take that instead of you watching me type this. So let's go to GitHub. And so the SignalR service bindings that we built, it's currently in this repository, and it's got instructions on how to use it. So the way Azure Functions works is that it comes the function host itself comes with some standard bindings like HTTP. I believe like some storage stuff is in there as well. But things like Cosmos DB, if you want to talk to Cosmos DB, or any custom bindings like this one that we built for talking to SignalR service, you kind of have to opt in. So this is sort of a new thing in version 2 of Azure Functions, whereas Azure Functions version 1, it literally just imports every single binding that the team is currently supporting. So it's a little bit of a change. I believe we probably did it for performance reasons. There's no reason to bring in every single binding if we don't need to use it. So somewhere in here, I have a sample, the simple chat. And let's just steal some HTML. Let's just more or less get this thing working, and then we'll make it better. And by better, I mean add Vue.js to it. So let's go here, let's paste in the whole thing. So let's go through this pretty quickly. We can actually start this, although nothing much will kind of come out of it. So network error. Yeah, of course, because I don't have anything running. So I can't show you the beautiful UI that I've built. Actually, I put 0 styles in there. The only styles I have is actually the hide and show things. So it's like a 1990s style chat app. But I'll quickly kind of go through what we're doing in here. So to talk to SignalR, the service, we need to bring in SignalR service, or basically the SignalR library. It's the exact same library that we use to talk to SignalR if it was in an ASP.NET Core application. So we reference that JavaScript. And my HTTP client of choice in JavaScript is Axios. So I bring that in so that I can make some HTTP calls to Azure Functions. Actually, I just realized that I haven't done this in a while, but I have a little to-do thing on the top right of my screen here. Let's type in there so that we know what we're doing today. So, so first thing we're going to do is basically we're going to create a simple chat app. And then we can probably deploy that to Azure. And then if we have time, maybe we can add auth. We're going to add Twitter auth. Might not have time for that simply because I need to figure out how to generate a Twitter auth key and all that stuff. So maybe we won't have that question mark there. But at least we'll create a simple chat app that actually stores the chat messages in Cosmos DB, reads them back, and then when someone sends messages, it will be broadcasted to everybody who's connected currently. So right now, the current application, get out of that. come back down here. So the current application doesn't store the data anywhere. It's literally the most basic chat app just to show how to use this binding that I've created. So to connect to SignalR, what we need is some connection information. In an ASP.NET Core application, so if I were running this inside ASP.NET Core, it's pretty simple. You actually just go / and then your hub name. SignalR, all messages are routed through hubs. And basically, the ASP.NET Core application takes care of basically any auth that you need to that you need to run in order for someone to connect, all that kind of stuff. To connect to SignalR service in Azure is a little bit different. You still have a connection string, basically a URL that you connect to. But what you also need is a token. And this token you kind of build out of a connection string. And if you actually added SignalR service to an ASP.NET Core application, the library actually takes care of all that for you. It's actually really elegant. You actually literally just add, I believe, change 2 lines of code in your SignalR ASP.NET Core application, and it's enabled to talk to SignalR service. It does that through a lot of the some stuff in the protocol. So when you actually connect to a SignalR hub, it actually talks to a negotiate endpoint. And then when it talks to the negotiate endpoint, one thing that it can do is it can actually return a URL to a different hub with optionally an access token. And that's how, when you add SignalR service support to your ASP.NET Core SignalR application, you get, it basically just works like magic because the protocol itself actually deals with all that. So the new stuff that you actually add to your ASP.NET Core application will basically deal with figuring out how to build that token and return this redirect to the user. Not to the user, to the browser. And then the SignalR library on the client side, this thing here, knows how to work with this redirect to actually now connect to this new place that it needs to connect to. But when we do this in Azure Functions, we kind of have to do a little bit more work. So that's part of what, that's one half of what the binding that I've built kind of handles. Without it, you would have to do quite a bit of work. Actually, I'll show you if I can in the code. So these extensions are written in C#. But like I was saying before, any language that you can run in Azure Functions can consume them. But I'll quickly kind of show the, where would that go? Let's hop in here and see if this is the one. Nope, that's not the one. Oh yeah, this thing right here. So if we didn't have this binding, what we need to do is actually we have to parse the connection string to basically pluck out the endpoint and the basically this master key. And this master key you really don't want to give to your clients, right? Which is why we have this only on the server side. And you actually use that master key, and you create basically a jot bearer token that you pass back to the browser, right? So this is what I'm doing right here, and here I'm bringing in another library, basically the standard ASP.NET or the .NET identity.tokens.jot library. And we're building out that jot token with the right issuer and all that stuff. And then we're returning basically a payload back to the browser. And then so now the basically the end result is we're actually not returning this to the browser, but the binding is providing this to the Azure function. And then the Azure function itself returns it back to the browser. So, and we'll write this function in a bit, but that makes the code a lot easier to basically generate this token. It's literally just this one line of code. So when the function executes, the binding passes a valid token to the function itself, and then the function is literally just returning it as a body over HTTP, right? And then on the client side, we call this negotiate function to basically grab this information and then pass it off to the SignalR client library to connect to SignalR service. So that greatly simplifies things, and we'll write this in a couple minutes. Well, basically we'll copy and paste this in a couple minutes. But all this does is that it facilitates the initial connection to the SignalR service. So long story short, that's basically what a lot of this code does. So when the chat app first loads up, it's going to call get connection info. And get connection info is literally just making a post to my negotiate endpoint, and then we return that data. And then with that data, which is right here, this info, right now it's pretty kind of silly. I'm just basically prompting the user for a username. Later on, and probably not today, we can add app service authentication, which is built into all web apps and function apps and basically anything in the app service family. That you literally just check a box, give it your, say if you want Twitter authentication, you just basically give it your Twitter app ID and your Twitter secret. And then it'll just handle all the authentication for you. And then the Azure function itself can basically grab the Twitter handle of the user and basically do whatever they want with it. And you also have the option of basically allowing anonymous access to your function, or you totally block it. And basically any call to the function will now redirect to a Twitter login. So you have a lot of control over that. But we won't. But just today, we're literally just going to prompt for a username, so anyone can just type in any username they want, and that's it. So I'm just stashing that into a variable. And then next thing we're doing, which is basically just grabbing all the elements on the screen, and we'll be changing this over to use Vue.js in a bit. So all this code will kind of disappear. But basically, we have the connection info, and the next thing we're going to do is this chunk of code here, which is to create a SignalR hub connection. So to do that, you use the SignalR hub connection builder. And this is where we pass in the endpoint that we retrieve from the server, and also the token, which you kind of have to pass in the form of a factory. So this is a bit of a hack right now. Ideally, what you want to do is that in here, you basically make that call to the function again. So basically, whenever it needs to connect, instead of basically just reusing that token that we got when we first opened up the application, what we really should be doing in here is that we should actually be making another call to the negotiate endpoint, get a fresh token, so that every time SignalR library wants to make a call, or basically make a connection back to the service. So for instance, for some reason it lost connection, it will grab a fresh token to connect to it. But for the time being, this will work. I think I created the token to be good for 30 minutes. So, and then if you get disconnected right now, you kind of have to just refresh the page. And then we configure a little bit of logging so that we see some stuff in console in the console. And then we just more or less build a connection. Another thing we got to do is basically create a function or a method, depending on which world you kind of come from, that will be invoked when there's a new message from the hub. So it's pretty simple, and if you've done stuff like with different kind of WebSockets or kind of like a real-time library like Socket.io, it's exactly the same thing. You basically just say, hey, I want to react to this particular event, and when that happens, take the parameter or parameters that I've got and pass it to this function. And then in this particular thing here, we are creating a new list item and appending it to a list that kind of shows basically this sender said this. Pretty straightforward. And you can also kind of bind to different SignalR events as well. So this one here binds to onClose. which will just more or less display in the console disconnected, so that we know that we've been disconnected. So what we can do, and maybe we'll do this in the future, is that you can actually basically plug in the reconnection logic in here as well. So you have full control over when to reconnect and how to reconnect, whether you want it to reconnect right away, wait 5 seconds, the exponential back off, all that stuff you can kind of do on your own, and kind of like based on the logic that you want. But that's kind of where you want to do this reconnection. And the reconnection is really simple. You literally just call connection.start again, which is the line that I have right here. This actually initiates the connection. And then when a connection has happened, all we're doing is that we're just logging out to console.log. And now our application is ready to go. And then down here is a little bit more stuff that's going to go away when Vue.js comes into play. We're just basically listening for the submit. Basically, when I press enter in a text box, and it's going to grab that message and send it off to an Azure function. And that leads us to the second function that we have called messages. So we're going to basically allow posting to this /API/messages endpoint. And it's going to basically just take the sender and the message text, pretty straightforward stuff. Currently what it does, if we actually go back to the sample, is that it just broadcasts it to everybody. So let's quickly go back to the sample here and see the other endpoint. So again, it's using a binding. So the first binding is actually to grab the connection info and return it to the user. This other binding is literally, I just call it SignalR binding. And it's an output binding, so you configure that in the function.json. So for those due to Azure Functions, one of the more powerful things of Azure Functions is that these concepts called bindings. And what bindings do is that basically you can say that I want to react to, say, an HTTP request, and that's what the HTTP trigger is for. That's built into the function runtime itself, so you don't need to send up an API gateway, any of that stuff. You literally, every function in Azure Functions can be an HTTP function just by basically giving an HTTP trigger. And then also the response over HTTP is also a binding, so that happens to be of type HTTP. Let me make this slightly bigger still. And yeah, so we're just basically literally returning the result to the browser, right? So that's the standard HTTP binding. We'll create one in a bit so you can actually see how that works in the tooling. But this is the magic here, right? So we now have a SignalR binding as well that allows us to output messages to a SignalR hub. So again, without actually this piece, what you end up doing is you would, and I'll quickly kind of show you that. I can remember where that goes. I think it's somewhere in here as well. Connection string. No, maybe not here. So somewhere I'm making an HTTP call. Okay, yeah. So to basically write an output binding, typically what we do if we want to support the outputting of one or more things to somewhere, we would implement this thing called an iasync collector. What it is just an interface that has a couple of methods on it. So one is add async. So basically, every kind of object you want to output, in this case, the output to SignalR hub, is we'll invoke this add async method. And then for sometimes you want to basically batch things up. So sometimes the runtime will call a flush async method as well. We're literally just sending this out to the SignalR hub as soon as add async is called. So we're just literally returning a completed task. For those in the JavaScript world, this is basically promise.resolve. Yeah, so when you read this, literally task is functions, or sorry, task is promises. And if you see any async await anywhere, it's exactly the same as JavaScript, more or less. I'm sure there's differences. So here's kind of like the main part, right? So when someone calls add async, and I'll explain what add async means in other languages outside of .NET, inside of an Azure function. But basically, when add async is called, we first create a SignalR connection string, and then we post to basically an HTTP endpoint at the SignalR service, right? So you'll see that I'm building a URL, which I get from somewhere. So that's the connection endpoint. And then the URL also has, then the rest of it is just a payload, I believe. I wrote this like 15 days ago. My memory is much shorter than that. But it's literally just a post to an endpoint with a token. This is a slightly different token. So otherwise, a client can actually take a token that we got from the service, and it can actually basically make calls to the hub, which would be bad, or basically make calls to the SignalR service, which would be bad. So this is actually a slightly different token that we're using. But basically, we're just more or less just making a post to the service. So not too many lines of code, right? But you don't want to write this every time you want to basically publish a message to your clients, right? So that's where we built the extension. And I see there's comments there, or so I'll get to that in a sec. Let me just finish. So now this is how we consume the function. So I kind of showed you this a few minutes before. You literally just add a new binding. And in Azure Functions, you can kind of have as many output bindings as you want. So if your particular function needs to be triggered by, say, HTTP, but you need to output to SignalR, to some queue somewhere, you want to save it to Cosmos DB. Each one of those is literally just an output binding, and it's usually a few lines of JSON. And we have tooling, especially in Visual Studio, the full Visual Studio, to actually help you kind of create these things, and also in the portal as well. In VS Code, I believe, and using the CLI, I believe it's kind of manual. We'll just have to basically build this ourselves. But we already have it here, so we'll just copy and paste it in. But you really just add this chunk of JSON there, and now we have an output binding that knows how to talk to SignalR Hub. And then the actual function itself, again, is super, super simple. So whenever this function receives an HTTP request, this function runs. It's going to basically receive the request. So the request itself, it can have query strings, but in this case, we only care about the body. And all I really care about is I'm actually just pushing it out, like basically just taking that body and basically publishing back out to a hub. So I showed a little bit earlier that async collector. So basically, you can return one or more messages or one or more objects to these things you want to output to. In this case, we're outputting to SignalR, and we're outputting basically an object, right? But there's nothing stopping me from basically returning multiple of these, and these will get pushed to all the clients in SignalR Hub, right? But right now we only need one, but we still need to return an array because behind the scenes is an async collector. But to JavaScript or to Python, I believe probably Java as well, all you're working with are arrays that you return. So in this case, we are returning, actually, I totally lied there. The array that we should be looking at is this thing out here. But same thing. So basically, SignalR messages is what I named this binding. So I basically just have to assign an array of things to it. And that array of things is what get published or basically get broadcast to the users. So you can see right here that that there is a kind of like a format that we're expecting this object to look like. One is that it needs a target, and what a target is it tells SignalR Hub which message to invoke on the clients. This is a new message. If we flip back here, you can see that we have a listener for new message, right? That's how the server invokes stuff on the client. And then these arguments, right? So in this case, all we're taking is the message itself as an object. But we can actually return multiple things as well. If that's what we need, you just kind of return that as an array, right? But basically all you have to do to basically publish stuff out to SignalR Hub is basically return, or basically add one or more of these messages to an array, and you call done, and that's it. So that went from maybe like 30 lines of C# that you probably don't want to write, especially if you're a JavaScript programmer. Although you can technically do this in JavaScript as well, in functions. If you know how to basically build that jot token, you probably have to bring in a library. And if you know how to make these calls using basically HTTP calls, you can totally do that yourself. But this is way easier to bring in the binding and just return a bunch of objects. Anyway, that is a tour of the binding. We actually haven't done any work yet, so we should get to that soon. But I see some stuff happening in chat. Oh, Clarkio's here as a Sushinator. Recognize you from before. I am doing core at the moment, or function via pure Ajax. So we're gonna basically work with pure, like basically we're working with basically just Azure Functions at this point with JavaScript. I was working, kind of showing through some of the guts of this binding for SignalR service that I built, which is written in .NET Core. It actually targets .NET Standard. But to actually consume it, you don't need to know C# or .NET or anything at all. You just more or less bring it in. I'll show you how to bring that in a sec. Yeah, good to see you too, Clarkio. Loziak, nice to see you as well. Oh yeah, you're still a moderator or something. I don't know what the sword is for. You can keep the sword. I totally forgot what that was about. Still new to this. This is like my probably 5th or 6th stream, and I haven't done this for feels like a couple of months. So anyway, let's write some Azure functions. Enough talking. So let's go back to my VS Code application here. So this thing will more or less work. So I'm just going to basically leave it as is, and then we'll add view to it later. We'll add saving the Cosmos DB in a bit as well. So we'll hop over to this function app here. And the first thing we're going to do is we want to create an HTTP function. So there's a couple ways to do it. One is using the CLI, so you can go func new something, and you can create it. A second way is if you have the Azure Functions, what's this thing called? Extension installed for VS Code. You can use it to do that as well. It's like I'm not signed in at all, which is fine. All I need to do is click this little button. And it needs to find this function app, which is kind of tucked inside here. So it's actually this thing here. Here's my function app. Okay, it says I want a language. So I want JavaScript. I'm going to select a runtime, okay, whatever that is. So yeah, we want beta, which is the version 2 version of the runtime. Hopefully that will become, or that will come out of beta soon. And the new function, this new version of the runtime, at least a couple of important things for it that it enables. One is that it enables cross-platform both deployment and development. So the runtime that we're running locally in a few minutes here on my Mac is actually the exact same runtime that is run in Azure. So we're actually testing with the exact same bits as we are running in the cloud. So version 1 only supported Windows, and version 2, which is called beta here, supports Windows, Mac, and Linux because it's been rewritten in .NET Core and .NET Standard. Again, that's still just an implementation detail. When you're writing Azure Functions, if you want to use just JavaScript, that's all you're ever gonna see. So we're gonna select beta, and then we're gonna choose HTTP trigger, and we're gonna call this one. We'll call this one. I think we call them messages or something. I'll call it create message. Should I? Send message. Yeah, we'll go with create message because there'll be a get messages later. Because we're going to want to support, we want to eventually save the messages to Cosmos DB and then read them back. So, and we can change his name later. We'll keep it the authorization anonymous. So you can also choose function level as well. The runtime gives you a key by default that you need to supply if you want to call it. But we just want to keep this anonymous. So that's it. So that's our new function. And it's already saved. It's all that. So I think all we have to do is press F5. Which I don't think is that simple. Let's see. It's one thing it didn't do. Yeah, I didn't know this was a an Azure Functions app. So let's get out of that. How do I stop this? I think it's already stopped. So for debugging to work, you need to know that this is an Azure Functions app. So I have no idea how to tell it that. Think about this for a second here. Clarkia, do you know how to enable basically like F5 and all that stuff in VS Code? I'm worried that because initially when I started it, open up the project, it asked me whether or not I wanted to enable Azure Functions support, and I quickly closed it, and now it's not asking me again. So let's figure out how that works. Maybe what I'm going to do is I'm actually going to close out of this. For that, let's nuke this folder. I'm assuming all VS Code stuff lives in here. Delete that as well. Now I'm going to close it. And what I'm going to do is I'm going to go back to the way it was, which is open up code just in the function app. Maybe that'll wake it up and or not. Hello? Oh, there we go. Okay. I detected an Azure function project. Would you like to enable all this stuff? Yes. All right, so it's doing it. So it's so things to JavaScript, all that stuff. I think it did everything properly. So now, hopefully, what this means is I can run F5. And there it goes. It's running, and you can see that I have this little messages endpoint right here. And I can now go into my Postman, take this, and hit that. And it's going to invoke my function. If I wanted to, I can actually attach a breakpoint. I don't know how many of you have seen this before. It might be a little bit boring for you. But now when I hit that again, I'll hit a breakpoint, and I'll see that I have nothing in the query, I have nothing in the body. That's why it's returning, please pass the thing in its query string. I can hop back to here, and I can pass it a name equals Anthony. Hit that again. Now if I mouse over it, it actually got the query string Anthony. It's going to say hello, Anthony. Very exciting. All right, there it is right there. Hello, Anthony. Took us an hour to get there. Amazing. All right. So now instead of basically doing this all over again, let's this is more or less copy and paste from GitHub. So we can get to something more interesting. So this is the messages thing. So we're going to copy this, swap over to our app, paste that in. So this is still going to be our function. We'll save that. Our functions.json, remember we need this extra thing here. I'm going to steal that from here. And if you want kind of full instructions on how this works, and go back to kind of like the home page here. And down here, there's kind of the same stuff here as well, how you kind of paste that stuff in. But I'll just literally steal it from here. Slap that in. So basically, this will publish messages out to SignalR. It's going to use a hub name called simple chat. Let's name it to chat. Another thing that it needs is it needs a connection string. By default, the connection string is called Azure SignalR connection string. So if I hop into my locals.settings.json, ooh, there's some interesting stuff in here. And I'll call this that. And then I'll need the SignalR connection string. While I'm here, I might as well plug that in. So my SignalR service instance has been deployed. So let's hop over to the resource. And we need some keys. I'm going to blow this away, so I guess I'll show the world my keys. Copied it. I'm going to hop back over to here, paste that in, save it, and that's it. So now we have support for writing out to SignalR Hub. So one thing that you also notice is that I named the endpoint differently. So what I want to do is actually, I want to change the route, but I totally forgot how I can do that. And it's not in here. It'd be in the HTTP input binding, or the trigger binding up here. I think it's some kind of a route. Oh, there is route. And I want to call this basically messages. And I think I can specify methods as well. And I only want this thing to respond to post. So now I have a more RESTful API. Yeah, I was pretty picky about this before in my last job about making sure stuff is like truly RESTful. I kind of backed off that a little bit. So now when we run this again, it's not found because is this even running? Oh, right, it's still running, which is great. Because I think we stopped. Oh, we did stop it though. Why is it running? Anyway, but if we go to messages, and we change it to post, it should hit something. It might not do the right thing. Actually did 200 OK. It probably pushed something to the hub, but there's nothing listening to it. So that's cool. So that actually may or may not have worked. And if we want, we can actually return that message. I don't know why you want to do that. Maybe we do. And if we want to return that message, it's literally res dot. Actually, now I don't remember what it is. It might be like context dot res dot body equals rec dot body, maybe. It's been a while. Now run it again. That's totally not it. I will need to back over here and cheat. So I know the negotiate one returns a body. So we return a body by, you kind of just do that. Kind of weird. I'll restart the function app. Maybe that's it. I'm not sure. Response body equals request.body. That's why I didn't send in a body. Boo. So I need to send in a body. I can send in a raw thing here. I can call this application JSON, and the body right now doesn't matter. I can just go hey, but later on it would matter because it needs to conform to a specific format. I think it's probably I probably need a sender property and a message property or something like that. But this will do. You can see that it echoes back hey, So it's just like that, super easy to return a response from your function as well if you want to. I'm not really going to do that because I don't think I need a response. Okay, so that is the function for actually sending messages, but now nothing is listening to it because we need to hook up that other side of things. So to do that, I'm literally just going to steal code. So I will create another folder, and this file was just called get connection info. Actually, no, it's called negotiate. And I'll just literally just copy paste some stuff in here. So I need a function.json that, and then that tells functions what the bindings are and all that. And we also need an index.js. And then back to my little repo here. And this is the index.js. Not that one. This one. Paste that in. We'll save it. So again, we'll go over this in a little bit as well. Maybe we'll even set some breakpoints to kind of show you what's happening. But for now, copy and paste, stealing code. It's my own code, and also I put the MIT license on it anyway, so hopefully I won't get a phone call from legal. I actually need the whole thing. So there it is. So basically it's an HTTP trigger, also outputs HTTP, and that it takes in the SignalR connection info. Maybe just a little sidebar to that. So right now, we don't pass any kind of parameters. Like it literally just creates a JOT that, or JWT, for that doesn't have any claims in it. But going forward, as we get more capabilities in SignalR service, so for instance, we should be able to basically provide a name identifier claim in the JOT, so that basically every connection can actually be associated with a user from the application. So for instance, if you kind of like allow Twitter login, you can actually embed the Twitter kind of user handle in there. And then that user can actually basically be logged on from multiple browsers. And because they're logged in under the same person in Twitter, when you connect to your function, you'll see it as the same person. And that function will return a JOT that has basically that same username for both clients. And then in the future, and then when it actually connects to SignalR Hub, then SignalR Hub actually sees that as the username identifier. Right now, it doesn't do anything with that. It does something with it if it was a full-blown ASP.NET Core application. But right now, the REST API, there's no way of actually targeting. So if we didn't use ASP.NET, if we just want to basically talk HTTP REST API to it, there's no way of basically saying, hey, only send a message to this user, which may or may be one connection or multiple connections. And that's where kind of like like adding the username claim, or the user identifier claim, will be interesting in that scenario. So right now it doesn't support that yet. But what I'm hoping in the future is that we literally just user ID claim maybe. We basically, I'll basically add an extra kind of property that we support in this binding, and then we can pass in a user ID. And you might wonder where would that come from. So if you're using something like app service authentication in app service, and in this case specifically Azure Functions, when someone is logged in and they call your API, it actually, the service itself sets a bunch of x-ms- blah, 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 some kind of principal name kind of headers. And one of them is actually the ID from Twitter, I believe. And if not, there's an API that you can call to actually get that. And because that's exposed in a header, what you can do in functions in a binding is say I want to be like user ID, for example. Instead of basically passing in, for instance, like me, right? That's my Twitter handle. I can actually pass in something like what's called a binding expression. So you can pass in, I believe it's like headers dot, and then it'll be like x dash foo, like x dash dot ms dash foo. And if that exists, that actually gets passed into the binding. So when we're actually building that binding behind the scenes, or we as in like basically when the binding builds the token, that jot behind the scenes, it'll actually embed that user ID in there as well. So that's something I'm thinking about in the future when we actually have that support on the other side. Another thing that I want to see if it's possible is right now we're actually taking in this token as an input binding, right? So I'm getting handed this connection here, right? And then I'm returning that back to an HTTP response. But can I flip that around and actually be like, hey, like just be a straight up, just a plain HTTP trigger, but the output be something other than HTTP. The output maybe be like a SignalR connection info HTTP response. I don't know how, like what to call it. And then that becomes like, like how we kind of like when we publish messages to the hub, we just literally just return an array of stuff. Perhaps we can actually do the same thing here. So instead of basically setting, context.response equals this body, you literally just go context.response, either an empty object, which will basically just generate like an empty kind of jot token or a jot for anyone to connect to the service with, or you can actually have like user ID in here, or basically multiple claims in here, right? That the output binding will use to build the jot and also return it to the browser or basically to the caller. I haven't figured out how to do that yet. I'm not even sure if it's possible to do this in Azure Functions as a custom extension. So I'll be talking to some folks on the team about that. But anyway, this works fine, works well. So to kind of close the loop here, we're kind of getting the connection info that comes from the binding, and we're returning that as the body of our method. So that's done. So we can actually now go and, is this thing still running? I forgot. Let's run it. So now this thing's going to get going. Or not. Is it going? It might be working. Who knows? Call this thing. Yeah, it's working. So we'll call the negotiate endpoint now. And nothing happens. And you know why nothing happens? Because we actually don't have the extension installed. So let's do that. So remember, maybe like half an hour ago, we talked about the V2 version of the functions runtime has some things that are common, some kind of bindings that are common out of the box, and then the rest of them, you kind of have to opt in. Anyway, let's check out the chat here for a sec. Whoa, what's happening here? Sorry, I've been ignoring you people. Is there a generator for these JS clients? Sushinator, if you can expand on that a little bit. Maybe like client as in like the browser client, or basically the JavaScript functions on the function side. So if you can kind of let me know that while I figure out this other thing. So now we're going to basically add the extension to the function. So to do that again, I forgot how to do it, but thankfully I wrote it in the README. So somewhere in here, it's right here. So the functions CLI has a command called extensions install. I'm going to hop back here. So we're in the function app. Let's bump it to the top. And okay, fine. Okay. So we're going to just paste this in. So all we're doing is that we're saying, hey, please install this particular extension. So an extension, all it really is it's just a NuGet package that lives on NuGet.org. And for those who are not in the .NET world, and again, you don't have to worry about this at all. this is like extra information, is that in the .NET world, this is how we manage packages, or this one way we manage packages, is using NuGet. And so basically in the JavaScript world, that would be equivalent to NPM, and Maven in Java, stuff like that, and gems in Ruby. So we can kind of have basically the CLI wraps a bunch of calls to NuGet and maybe to the .NET CLI to actually basically pull in the package and put it in the right place. So actually, before I run that, I'll do a listing here. There's not much going on here, right? So it's basically like a couple of folders and a couple of JSON files, some hidden folders as well. But as far as our code is concerned, not much going on here. But what we're going to do is we will run this command. It's not going to go out to NuGet, hopefully, and pull in a bunch of stuff. And that is the extension that I kind of built and published. So now we do an ls. You can see that we kind of got more stuff. We have a bin folder now. We have an object folder. Like those are kind of like .NET artifacts. Again, you don't have to worry about any of that. The git ignore, I believe, ignores those by default, as they should. There's a couple of important things here. One is there's now this file called extensions.csproj, and we'll look at that in here. So you can see that it created this thing. Again, you don't need to really worry about what this thing does, but this is what tells Azure Functions which extensions you need to pull in when you say publish this to Azure. So when you publish this to Azure, it won't actually publish the bin folder or OBJ. Those are both grayed out, which means they're actually in the git ignore file. So when we publish this out, it will publish out this extensions.csproj, and then basically the thing behind the scenes actually basically publishes out the functions. We'll actually run the proper commands on it to actually do a proper build. That will regenerate the bin and the OBJ folders. So that's why this file is there. For you don't really have to deal with it. You literally just run func, where did it go? Func extensions install to basically add stuff to it. I believe there's probably stuff, there's ways to remove stuff from it as well. Yeah, so then the other thing that's interesting is that so when this stuff is pulled in, we actually run a .NET build. Even though there's technically no CS files in here for us to build, it still kind of basically runs a build. And what it does is basically it creates this bin folder. And in here, this bin folder, you can actually see that in my csproj, which kind of basically tells the runtime. In this case, like the .NET CLI, when it does the restore and when it does the restore, to also pull in this extensions metadata generator. So this just magically gets pulled in, but during build, this extensions metadata generator actually generates this little file called extensions.json. And so basically what it does is actually goes and inspects all the DLLs that are living, I would imagine, probably in your bin folder. And basically figures out all the bindings that, binding extensions that have been installed. So when the function's runtime starts up, right? So it's different from deployment. So deployment, it basically uses the csproj file to do a restore, so basically to pull in the extensions. But this extensions.json file, and I've lost that again. Let's find it again. So this extensions.json file actually tells the function's runtime when it's running at runtime that there is a SignalR kind of binding. So when you start up, please pull that in as well. So long story short, hopefully this is all the work that I need to make this happen. So kind of weird that I can't stop the thing. Oops. Okay, so it's starting the host again. So I wasn't convinced that the host was restarting, which is why I tried to basically kill it manually. So now I can see, well, it was there already kind of thing, my two endpoints. But what I'm expecting to see is when I call negotiate, that it'll actually go off and create a token and return it, which it does right now, right? So before it wasn't working because I forgot to pull in that function bindings extension. But now I have pulled it in. So basically it returns an endpoint, returns the access key, and basically that's what the JavaScript is going to go off and use somewhere. Let me find that JavaScript again. Oh, I don't have that open anymore. So let's open the file. It's out here somewhere. Over here. So I'll open up this file as well. So this is my JavaScript file. You can see that I look for connection info dot. I'm trying to drag this out because I'm stalling because I'm looking for that line of code. Maybe if the person that wrote this, me, actually put some new lines in here, it would actually help. But anyway, there it is. So I plug out the endpoint, I plug out the access key, and that's what we use to connect to SignalR. And I believe, I don't think this thing's running anymore. Let's run this thing. It doesn't work, so something is not right. Oh, I might know why. So next thing we're expecting to see here is that it's actually going to call negotiate. Well, that actually worked though. What happened? So you can see that actually returned the endpoint. So there might be some JavaScript, a client-side JavaScript that's not happening here. Let's take a look at what it's upset about. Aha! So that's what I was kind of expecting. So so by default, the Azure Functions runtime does not deal with cores. So we can make it deal with cores. And I totally forgot how we can do this. I know I can do this by... All right, let's go back to the chat. Okay, nobody's talking. Let's figure out how I can stop this thing. Come on, stop it. Okay, so we've stopped the application. So I think we've stopped the functions runtime that's running inside VS Code. I'm going to hop out here, and I'll create a new tabby thing. And I'll go func host start. And I think you can pass in cores. So cores is right here, comma separated list. So, and I wonder if I can just cheat and just go star. Not gonna like it, or do I? Well, we'll find out. So it's gonna start up now. Now when I refresh this thing, it still says network error. So it looks like I have to be explicit about that. It's localhost 3000. So now if it breaks, we should see at least a different error. The address is already in use. Why is that? Looks like it's still working, but I don't like those error messages. What does it want? I have a feeling something is still running. I don't know what. I think it's gone. I'll start again. Hopefully the red stuff will go away. There we go, much better. So basically, Functions has the runtime and also has the language worker. Those red stuff before looks like the language worker running behind the scenes, which talks to the Functions runtime over gRPC, were not shut down properly. So basically, when it tries to start up in another kind of language worker, in this case for JavaScript, it's like, hey, I'm already there. I can't use those ports again. I believe that's what those errors were. And somehow what I just did there killed everything. So that's good. So, oh yeah, I'm supposed to go back to here. No, not to here. I'm supposed to go back to my browser. And look, it actually worked this time. So I'm going to say I'm Anthony. So you can see that I'm connected to the hub, right? So if I talk now, close that down, go to console. If I now say, hey, oh, you know what the other problem was? And this one's totally my fault as well. So over here, I renamed the hub to chat. Over here, I believe I did not rename the hub to chat. It's still simple chat. So basically, the connection info is telling me to connect to this thing called simple chat, wherein I should be connecting to chat. So let's refresh. This time I am connected to chat. So hopefully now we'll say something. So hey, so you can see it's going. So if I open up a new browser, paste that in. Someone else. I'll say yo, and it's working, right? So it's magic. So this is the local functions runtime. So basically my local SPA, written in vanilla JavaScript, talking to functions, running on my local host, talking to, what is it talking to? The Azure SignalR service that this thing is also connected to, and that's how they're talking. So totally working. Oh, hey, thanks, Clarkio. You've given me a link. For cores. Let me copy this or rip this one down here. So yeah, it looks like this is for running in the cloud. So yeah, running in the cloud, what we got to do is we're going to turn on cores, I believe. So locally, actually no, it's right here. Hopefully it's the same thing as I did. I don't remember. But yeah, so there's a way of specifying the core settings from running locally. Hopefully somewhere in here it's talking about that. Let's leave it at that because it's kind of running. So now we got this thing working. It took way too long. So what do we want to do? So one thing I could do is basically add Vue.js to it. Or we can start saving to Cosmos DB. I'm leaning towards Cosmos DB. It just seems a little bit more interesting. I hope. Let's see if that's really true. So to do that, so another thing that we got to do now. Okay, so stopped. Is that Cosmos DB, we need to add the extension to it as well so that we have access to those bindings. So we're going to go to look up how to do that. So we can actually go to Azure Functions, documentation, Cosmos DB bindings. Somewhere in here, hopefully, is that it talks about this thing that we're going to bring in. And this is the package name, and that's the version. So what we're going to do is go find my, no, not those things. It'll be func extensions install, and I need to give it a -p and a -v. So I'll go -p, and then I will just copy and paste that thing in. -v is the version. I am in the right folder. So, func extensions install. Now it's going to go off. It's going to go pull down the Cosmos DB binding. Complaining about a bunch of stuff. Hopefully that's fine. 6 warnings, no errors. I think that's a win. We'll go in here. I don't care about that. I don't care about that. So VS Code still thinks that this is a that this thing is a .NET project. So and I have kind of like the C# kind of extensions installed. So it's like, hey, you want to build your project? And I'm like, no, not really. Something else is doing that for me, which is the functions CLI. So to use this, actually, so what I'm going to show you again is that now we have an extra line in our extensions.csproj saying that, hey, Cosmos DB is now needed as a binding extension. And just to go full circle, to be fully complete, or to basically finish the loop, close the loop a little bit, you can see that in extensions.js, same thing. That got discovered as well. So at runtime, it will load this thing as well. That's great. So, so now we have to actually talk to Cosmos DB. So first thing you got to do, and I discovered this almost kind of like the hard way, is that the documentation is still somewhat focused on V1 of Azure Functions. So, and the reason I know that is because if I go down to the input attributes, you can see that it wants me to use this thing called document DB, which is the old name of Cosmos DB. And in V2, we actually changed the bindings to be called Cosmos DB. So, so I kind of have to Google that. Cosmos DB attribute. I think there was one person that actually did a pretty good job of explaining the differences. Might have been this person. So yeah, what he's saying is somewhere here that, and this is C#, and we kind of use it the same way in JavaScript, so don't worry too much about that. Is that in V1 it was document DB, in V2 is Cosmos DB, and I think after this we got to go and actually figure out how to update docs to have it reflect the right thing. And also talks about basically the connection string setting. Where's that link to? Nice. It actually links directly to the code. So this is the setting that we need to set to talk to Cosmos DB. Somehow I lost my, oh, there it is. My menu bar went up to my other monitor. So, what do we gotta do? We gotta do something. I don't know what we're doing. Oh yeah, so I copied that thing. So first of all, we need to set the setting. Called Azure Web Jobs Cosmos DB connections string. Wow, that's long. Okay. And now we need a connection string for Cosmos DB, which we have somewhere over here. I really should try my best to kind of hide this. Let's see if this actually works. Go to keys. So all right, so I have my connection string right here. I'm going to copy it. Although now that I want to paste it in, everyone can see it anyway. So here's my connection string. Don't look too closely. So now I have my connection strings. So now my Cosmos DB bindings will know how to talk to my Cosmos DB. So next thing I got to do now is go back to this person's, maybe not this person's thing, but go here. So now what I want to do is when someone sends a message, I want to save that message out to Cosmos DB. So to do that, I need the attributes. Is there like a JavaScript example? Oh, there it is. And I need an output example for JavaScript. So here it is. So I'm just going to literally just steal this chunk of JSON. So when I create a message now, what I want to do as well as outputting it to SignalR is I also want to output it to Cosmos DB. So we're going to call this a Cosmos DB messages. Let's just be one message. Message. Will we ever support more than one messages? Probably not. And the type is actually now called Cosmos DB. And the database name, we don't have a database name yet, so we'll just call it chat. And we'll call the collection name messages. And we'll create if it doesn't exist. And the connection, I think we can just leave this out because it's going to read it from that default one that I've set up. I hope it will anyway. We'll find out soon enough. We'll save that. The other thing we got to do is go here. So now we also have to output to Cosmos DB. So we'll go context.bindings. I forgot the message or the name already. Not you. It's going to be called Cosmos DB message. Equals, and I'm just going to literally save the request.body. I'm actually hoping that that is actually a I'm hoping that's an object. Well, I guess I'll never know. Well, maybe I will. Let's see. Look at my network. Nope. I'll have to read code. Make sure that is a object. Where's my index.html? Somewhere up here. So when it sends a message, yeah, it builds an object. It builds an object with properties sender and text. So the body is an object, which is fantastic. It's exactly what I want. So that should be the entire line of code, all one of it, to save out to Cosmos DB. So let's go func host start. And cross some fingers. So now I go back to this application, refresh. It's going to ask me for a name. And I'll go, hey. So it went to SignalR. So now what we're going to do is we're going to see whether or not it actually went to Cosmos DB as well. And oh, something happened in here. And you can see I have one message. and actually saved it. So that was all I needed to do to basically write to Cosmos DB. Magic. So I'm going to do one more thing, and that is I need a way to basically, when the app loads up, to actually pull down like basically the last, say, 100 messages or whatever it is, so that anyone connecting will have context to what people are talking about. So to do that, actually, it's bothering me a little bit. I don't know why I'm defaulted to 4 spaces. It should be 2 spaces. Yeah, I shouldn't worry too much about that, because if I did that, I'd be fixing everything. All right, so we're going to go quickly create a new function to actually read back messages when someone connects. Go here. Actually, no, let's try the CLI experience. Let's try them all. I think we are in the right place. So we're going to go and go func new, I hope. And it's going to be like, hey, what do I want? I want HTTP trigger, because I want this. I want the web app to actually go and call my this endpoint and pull back a list of messages. What I want to call it, I'll get messages. And that was it. Oh, that was too easy, actually. I was hoping that it would ask me about anonymous and all that stuff. But let's close some stuff. Close others. I need get messages. Let's check it. So yeah, you can see the auth level is function. I want to change that to anonymous. Anonymous. And another thing I need to do now is when I execute this function, it will just basically it's just a plain HTTP trigger at this point. How do I get documents out of Cosmos DB? And I will have to copy and paste some code. So now what I want is, instead of an output binding, I want an input binding. So another kind of cool thing about Azure Functions is, just like you can have as many output bindings as you want to a function, you can have as many input bindings as you want to a function. I'm sure there's a limit somewhere, but I mean, usually you get 2 or 3, and that's all you really need. So what we want to do is we want to create an input binding that will actually pull in messages from Cosmos DB. So to do that, this, I believe, is the thing. No, this is still in the output. So I want the input. I want JavaScript. And this is the document in right here. And I will paste it in here. And we'll call this basically messages. This will be that kind of like the argument that my function will take in. Just like before, this thing now is called Cosmos DB. The database name, I believe, was chat. Chat, and messages is the collection name. Messages. And if I don't want to set this everywhere, I can actually set them as basically app settings or environment variables. And then there's actually a way of kind of like, you can wrap them in like, oops, like percent signs to actually reference environment variables. But I won't do that. Why does it need a queue trigger thing? Okay, oh yeah, that's right. Okay. So so there's things you can set here. So this particular example is telling it to pull back one message, right? So you do that by basically setting the ID of something. So in this case, you can actually set it to something that came in from the trigger. So for instance, if I say like I pass in a name or an ID as a query string or the body, I can actually literally just hit ID there, grab that from the input, which is the HTTP request, and then it'll actually pass that in to the Cosmos DB input binding, and binding will use that to look up the record or the document and return it. But we actually don't want that. What we want is, and we don't need the connection either. What we want is something like a query. I think it's like a SQL query. And I need to look this up like everything else. SQL query. Yeah, so use a SQL query parameter. So even though, like I was saying before, even though we are dealing with a document database, a NoSQL database, we're going to query it with SQL. And the syntax is fairly simple. We're going to go select star from C. For some reason, the actual collection is referred to as C, so I'm just going to do that. And I'm actually going to basically go order by. And then if you actually poke in here, you can actually see that the record itself, it's automatically, it automatically adds a timestamp to everything that I put in. So I will actually sort that in descending order. So order by _TS, I believe, descending. So it's going to basically pull back all my messages in reverse kind of order. I'm going to save that. And I think that's all I need to do to make that kind of happen. And then in my function here, here's my boilerplate again. This is basically going to ask for a name. I don't want any of that. What I do want is actually I want to take in a parameter called here messages. So I'll copy messages. I'll take a parameter called messages. So before this function is even called, the extension, or basically the binding, is actually going to go out to Cosmos DB and pull back my documents that I've asked for. So the very first line of code that I write in my function will not only have access to the HTTP context if I need it, but also basically my data that I want from Cosmos DB. That's another pretty cool thing. I've actually, like I've played with other kind of serverless kind of products before, and like this is something that's pretty unique to functions. Again, like you really just focus on writing the code that only you know how to write, and anything that basically, you copy and paste 30 lines somewhere is actually to read from or write to a database. The bindings take care of all that now, which is a huge benefit to Azure Functions. So what I'm going to do now is that I am literally going to go context.response.body equals messages and see what happens. I think that's all I need to do. So I'm going to run this thing, and I'm going to go back into Postman. Oh, so another thing I got to do, well, yeah, let's just hit this endpoint, but I want to rename this so that it will only react to GET, and it'll be API/messages. But let's just try this out. So I'm posting, doesn't matter what I'm doing. So hopefully, oh, I get a server error. That's bad. Doesn't like something. Oh, TS cannot be resolved. I know exactly how to fix that. So it's a little bit different than SQL syntax. So it's been a while since I wrote SQL too, so I mean, I wouldn't be surprised if I made some like plain SQL errors, but I'm actually have to go c._ts there. How do I know that? I make that mistake every single time. Now let's see what happens. So I should get back, here we go. I got back my array of stuff. To be more efficient, what I want to do probably is to actually like map this to just have sender and text, and maybe the timestamp on it, send it to the UI, like ignore all this other stuff. But just for convenience, I'll just leave it at that, right? So now what I do, if I go back to my application, oops, somewhere over here, and go, yo, what's going on? Now if I go back to Postman, I have 3 records now, right? So so that's all I need to do. So I have about, let's see, 10 minutes left before I have a meeting at lunchtime. I love lunchtime meetings. I will try to basically make the UI load the messages, and I think we can call it a day. We'll have to save kind of like the publish to Azure and the the like making it look nice in view kind of thing for next time. And I really want to add in the auth as well. So, but that'll be for next time. So let's go back to VS Code and in next.html, somewhere over here now. What do I want to do? So when I am in here, but before I even connect, yeah, why don't I have new lines? I'm very disappointed with myself here. There you go, a little bit happier. Oh shoot. New line there, new line there, or no new line there. Okay. So what we want to do is that before we call connection.start, let's go ahead and do something else. And that something else will be, well, there's two things we've got to do. Sorry for being like hopping back and forth here. Once again in here, what I want to do is, so this is the get messages HTTP trigger. I want to give it a custom route, and I'm also going to call that messages. So now there's going to be a clash between basically create messages or create message has basically the same route, but it's limited down to post. So I want to change this so that it's limited down to get. And that's just me being anal and wanting to make it as restful as possible. So right there. So now when I save it, this thing will no longer work. Yeah, 404. But if I go messages and I change it to get, and I'll get back my stuff, right? Great. Amazing. Okay. So now that's happening. So we're just going to quickly make this change. So copy and paste. And the function. This one is get messages. I don't need anything here. Still need the base URL, and it's now a get. Same path. There you go. That should be all I got to do. So now I can get messages. Oh, geez. Okay, okay. This thing wants to refresh every time. Live reload. So now I'm going to go up here. And before we call connection.start, we're actually going to go console.log retrieving messages. Interesting. I decided to write semicolons for this one. A couple months ago, I decided to switch over to no semicolons in JavaScript, at least client-side JavaScript, and I kind of like it. But anyway, not to kind of start a big discussion here. So now I'm going to go and get messages. And then when that happens, I'm going to get basically some messages here, I believe. And this is when I will go ahead and try to connect. But before I even try to connect, what I'll do is I will, there should be a thing here, new message. So I'm just going to call new message. So I'm going to go, basically, I'm going to go basically for each, for, what is it, like let. I don't know, it's switching between JavaScript and C#. It's hard. Let m of messages, something like that. And then where's my new message? I don't have a thing called new message. Oh, that's kind of sad. Okay, I need to extract this out to its own separate thing here. So I'll call this, I need a verb. I have no verbs. I'm just going to call a new message. I probably need to pass in the message object. Is message.sender, message.text. So we're good there. This thing right here, I no longer need. And I should just be able to go new message. But now in here, I can call new message. And I'll pass it my M. There is, I don't know, like a 50% chance this might actually work. So there it goes. I'm going to go Anthony. Hey, it worked. What's up? I'm still inserting to the bottom. I have no idea how to insert it to the top. Vanilla JavaScript append to as first child. Prepend. No way, really? That's all I gotta do? Let's see over here. Where's my new message? Actually, no, that's no, that yeah. So I gotta for each one. Ooh, yeah. Actually, that's kind of weird. Because I kind of got these messages back in kind of reverse chronological order now. So now I'm actually gonna play them. I have to play them back in the other way. So, okay, vanilla JavaScript. Reverse an array. So it's gonna be like array.reverse, yeah. Of course. And this is, okay, perfect. That's exactly what I want. So I'm gonna call array.reverse somewhere. Right here, .reverse. Beautiful. And then here, I'm gonna now, when I get a new message, I will prepend. Can I do that? Are you lying to me? Okay. Nodes to prepend. Okay, well, I don't know. Is that gonna do anything? It didn't restart my page, which is a little bit concerning. So now when I kind of say something, latest, pops, oh, pops up at the top. So I think that's right? So obviously I want to kind of reverse that again, move the box to the bottom and all that, but I don't know how to do it right now. But anyway, I got to wrap up. So what did we do today? Not much. I think I just did a lot of talking. Experimental. You mean the stuff that I'm doing here is experimental? It totally is. But anyway, let's finish up by kind of thinking about what we just did. So we created a brand new function app. We did pull in basically some pre-done kind of SPA, single page vanilla JavaScript kind of application that I wrote before with some really ugly JavaScript that talks to a SignalR hub. We talked about how we can add a SignalR binding extension. Oh, the prepend API was marked as experimental. Oh, darn. Well, that makes me sad. Is there another way to do it? I guess I gotta fix that. But funny enough, really the entire thing here, like the SignalR binding right now is really experimental right now. We're actually talking with the Azure Functions team to maybe actually getting that extension included, or not included, but basically moved into a more official kind of place, so that it would kind of be be managed the same way as we do with the, say, the Cosmos DB binding, or maybe the durable functions binding, which is its own separate repo. But anyway, we have to kind of sort that out. But anyway, so we kind of created 4 functions. One of them is just to facilitate the connection to SignalR, the SignalR service. The second one outputs, basically receives messages that are kind of created from the browser, and it outputs it to both SignalR, the SignalR hub, so basically all clients who are connected can receive it. It also saves it to Cosmos DB using another output binding, so we have 2 output bindings here, actually 3 if we include the HTTP. Really simple to actually work with output bindings. You literally just give the SignalR message, or the SignalR output binding, an array of stuff, and it will just basically just send each one of those items as a message to all the connected clients. And then Cosmos DB, even easier in a sense, in that I just literally just assign the object that I received from the browser and save to the database. Obviously, I probably want to do a little bit more kind of validation on it, because people could be posting all sorts of weird stuff and kind of like more or less using my Cosmos DB as their own database for their own purpose if they wanted to. So kind of want to basically do some validation there, but just starting off, that's pretty cool. That works. So literally, like how many lines of code is this? Like 7 lines of code, 6 lines of code. We're able to basically write stuff to a bunch of clients and to a database. Get messages is even easier. So get messages is called when our application starts to kind of get the messages from before. It's, again, just a standard HTTP trigger and output binding. But we also added an input binding for Cosmos DB. Gave it a query to how to basically read back some data. Basically read back, right now, all the data. I have to figure out how to basically limit it to, say, 100. And kind of read back the latest in descending order. And the function that returns that is literally, I just took the messages I got from Cosmos DB, and I'm just returning it directly in the HTTP response. Again, if I want to do more stuff in here, like basically, basically map it to a simpler object, so that we send smaller payload down the wire, we can totally do that. But right now, I don't know, just for fun, that's probably good enough. And this is really like, so my end goal of this actually basically turn this into a demo for 10 minutes last week that I'll do in Perth and in Singapore next week, where I'll use this to introduce Azure Functions and bindings, right? So I'll start off with basically that HTML file right here, already working, or not working, already pre-built. But what it will do is, like, when it starts up, it just won't work. Because it doesn't have a backend to talk to, right? And then I'll basically have to build what I just did in 2 hours here in 10 minutes. It should be fairly simple. There'll be some copy and paste. Like, I mean, I don't think I'll need to kind of build the negotiate endpoint. I'll literally just drag that in from somewhere. The get messages and the create message. That's I might just end up kind of just dragging it in as well, and maybe using snippets to do it. So I don't have to basically, I'm probably freaking out on stage. I don't need to, further complicate things by having to memorize what I should be doing. But anyway, so I'm going to hope to use that to kind of show off basically, the fact that Azure Functions bindings are really powerful. You can have custom bindings, even, like some random person on the street can go create some custom bindings like me. And also you can basically use, like really simple few lines of code, and you can get HTTP out of the box. That's cool. So that's what we did. We built that today. Unfortunately, we didn't get to publish it to Azure. We'll do that next time. And we'll also basically, the other thing I want to do is basically right now, when we get the message, we're publishing out to the hub. We're basically publishing it to all the clients right now. But what I really want to do is actually is to remove the output binding from this particular function. So basically not have it output to SignalR messages to the SignalR hub here. So literally when someone sends a message, I just create the message. which is kind of why I named it create message, because you can actually set up a Cosmos DB trigger that basically listens to all creates and updates of items in Cosmos DB. So I can actually, on the flip side of that, in that function, have a SignalR messages output. So basically, whether a document was created using this API or something else, although that would be kind of weird, I would still be able to broadcast that to the world. That's kind of more kind of Firebase-y. So that's another reason why I want to kind of do it. Is that like we've been kind of wanting to figure out a way to really easily connect clients to react to changes in Cosmos DB and really just anything in Azure, right? So we're seeing this. We're hoping that this the SignalR binding and basically the integration with SignalR service will help us do that. But anyway, I'm 4 minutes late for my next meeting, so yeah, thanks for everyone for coming, and I will see you next time. Bye.